Okay, so another myth or misconception that I pretty commonly hear about the glow plug, specifically in these old IDI diesels, is that the reason they burn out is because hot fuel is being shot directly onto the glow plug tip. Now, I think they are a compacted graphite glow plug, but I'm unsure of that being the case, right? But let's connect the battery in it. So I just reconnected the batteries in this diesel, and the truck's cold, right? I haven't started it in a hot minute, but as you turn the key to the on position, you'll notice that the glow plug light turns on as the postman. And you can hear there's a slight whining. And notice how that whining keeps going? That is the glow plug cycling. Hold the throttle down as you try to start it. And then give it some throttle until it starts up. But you'll notice that amp or that voltmeter kept going down even after the light went out. That wait to start light just tells you that the glow plugs are hot enough, that they're providing enough resistance, because their resistance increases exponentially as they increase in temperature, right? So those fuel injectors spray onto the glow plugs while they're still being energized, right? Power is still being supplied to those glow plugs. They're cherry red, but the compacted graphite can take that. However, they're like a spark plug, they're a normal service item. Okay. So cylinder number 2 is the one that I know to be misfiring. So we're gonna take some BB Blaster and spray it around the injector and see if it's bubbling. Okay, today we're going to be making a video about common problems with these old 6.9 and 7.3 indirect fuel injected diesel engines. This one happens to be a 7.3. As you can tell, this block has been sleeved. It's got standard size pistons in it. They're 2 valve per cylinder engine, gear driven, of course. There's your crank gear, cam gear, and down here normally would be a gear driven oil pump. I have a melling unit to replace it. It's got a mechanical fuel pump on the side of it, mechanical lift pump that is. Single thermostat on the side of the block. This is where your injection pump gear housing sits. The injection pump is also gear driven. It has hydraulic roller lifters run off of a single camshaft in the block. Normally these are a dry liner, integral type liner engine. Single casting, I think the block weighs about 300 pounds without anything in it. This one's currently got pistons in it. As you can see, it's a closed deck type block with 1, 2, 3, 4, and I think 5. Or there's the 5th. Yeah, count them, 5 bolts per cylinder. That's your block drain. Let's go ahead and swing this puppy out. I don't think that you're supposed to deck these blocks more than 0.010 of an inch, because you can encounter clearance issues between the flat cylinder head and the pistons. Here's a block heater, and there's where your dipstick would go, and there's a little adapter on it. These, of course, have a 4-bolt main, and they're 5-main engine. These non-turbo IDIs have a little bit thinner of a connecting rod and a thinner wrist pin, full floating wrist pin. 2 of these, of course, 2 rod nuts and bolts. They have, I don't know if you can see that up in there. Right there, they have piston oil cooling jets for underneath the pistons, and those are, I think, are supplied by a little bit larger oil gallery in the turbo blocks. The turbo blocks are a little stronger, 17% bigger oil galleries, bigger wrist pins, connecting rods, and different pistons with keystone piston rings in them. So they don't recommend turbocharging these non-turbo IDIs. Anyhow, these are a forged and nitered crank, which can be cut by machine. You can go 10, 20, or 30 thou undersize after that. Junk the crank. I think there's 10 oil pan bolts per side. Cork gaskets, which are a pain in the ass. But you can do these in the truck if you undo the motor mounts, disconnect the coolant hoses, and then lift it out. There are nine threaded cap screws, which hold the flywheel to the crankshaft flange here. And then, much like a 7.3 Power Stroke, the rear engine cover, or the rear crankshaft cover, presses the Teflon type or PTFE polytetrafluoroethylene type seal into the back. Install that dry. As you can see, there's a little bit of a lip right here where the old seal wore into the crankshaft. This is the pickup truck adapter plate. As you can see, this adapter plate is bolted to the engine block by these 2 threaded cap screws. There is also a round type SAE bell housing for buses and medium duty trucks. I think these went up into the F5, 6, and maybe the 700 series Ford medium duty trucks. Not a particularly powerful engine. I think this one is rated at 170 brake horsepower and 338 pounds of torque. I don't remember at what RPM. Anyhow, they're really quite a simple casting. Not a lot to them. The valves, or the whatever you call these lifters, are held in by a single plate, which acts to hold down the bridges in between each pair of lifters. Let's go ahead and push this back. All right, moving over to the cylinder heads and the other assembly. Don't mind the complete mess in the shop. They have an external type oil cooler, as is seen on most medium and heavy duty diesels. They have a single external fuel filter. These are the standard log type exhaust manifolds with 2 bolts per cylinder. They have a standard vacuum pump, as well as, you can see, this is your injection pump gear housing. Those are your lifters up here. As you can see, it's a hydraulic roller type lifter. Roller in the bottom. Check those against the crank. I have a whole bunch of parts for them. There's the shitty old harness. I have new valves and valve springs. I have a couple of gasket kits. There's your harmonic balancer, and there's your water pump outlet. Now this illustrates one of the primary problems with these IDIs. People complain about getting them to smoke, but I don't know if it was this one. Maybe it was... No, it was this side. Okay. You can probably hear this. I can catch my finger on the crack in the cylinder head. It's very common for these to crack the intake valve seats. I don't know why I'd expect it out of the exhaust valve seats, but they commonly crack the intake valve seats, and they commonly crack between the cylinder heads. They are repairable by a big shop, but not by me. These use hardened steel valve inserts and a, oh, you can't really see that, can you? That's an in-canal stainless steel pre-combustion chamber. And as you can see, there are small cracks in it. These cracks aren't a problem until they get past the fire ring surface there. Okay, what else? Oh yeah, this is the retainer for those valves. And there's another gear housing. That, as you can tell, it's for a 7.3 because of the outlet cap instead of the one that comes out of the front like a 6.9. And then these 2 wires in the back are for the tachometer. This is an air conditioning compressor off that same engine, and this is the water pump. This, I think, is the this is the inlet to the block. That comes out of the bottom, and that is a 7.3 fuel filter housing. As you can tell, it's quite complicated. 6.9s are better because they have fewer attachments on them. These are the Stanidine injection nozzles that mount into the pre-combustion chamber. These are a pretty common problem in that these copper crush washers that go around the bottom will not seal against the cylinder head because the bore and the seat that have been cut get eaten away because people don't change their injection nozzles. You have to take these out and test them on a injector tester or a poppet nozzle tester every 50 to 100,000 miles. Depends on the kind of driving that you do and towing with it, but as you can tell, this is a VVOR injection nozzle tester. I think it goes up to 8,000 psi, and this is how you test it with fill that up with diesel fuel. crank on that handle with this in it. Check the spray pattern, check for leakage and drips, and check the pop pressures. They're pretty simple to check, but if you don't do it, you run the risk of washing your cylinder walls down with fuel, as well as overheating the engine. Overheating the engine is one of the main causes of cracking a head. These generally don't warp the heads, at least in my experience. I've worked on many of these, but they will crack heads. I've taken apart 2 6.9s and a 7.3 like this recently, and all the heads off of all of those engines were cracked, primarily because people don't check their injection nozzles and they overheat them. Another cause of overheating can be lack of coolant maintenance, which is a big problem. We'll come back over to that engine block right now. The 6.9 liter has a 4-inch bore and a 4.14 or 4 and 140,000th stroke. If I'm not mistaken, it's slightly under square, whereas this is a square engine exactly. So this is a 4 and whatever 1.5 bore and stroke, or somewhere thereabouts. But the cylinder walls on these are 100 thousandths thicker. On a 7.3 or 100 thousandths thinner, rather. The 7.3s have a 100 thousandths thinner cylinder wall, meaning that you have to be religious with your coolant changes. If you aren't religious with coolant changes, then you increase the acidity of the coolant A, which can eat through head gaskets, as it did on my Tacoma, common problem for the 4 liters, but it can also cause cavitation to occur around the outside of the cylinders. If I had a freeze plug out, I could show you one of these freeze plugs you could see onto the back of the cylinder. I could show you, but it'll cause tiny vacuum pockets to form against the outside of that cylinder wall. And that isn't necessarily the problem so much as the collapsing of that vacuum pocket, which will take tiny or microscopic amounts of steel away, or of cast iron. It depends on whether it's been sleeved or not, but either way, it'll take tiny amounts of metal away from that cylinder wall, and eventually it'll eat through the cylinder walls. You have to be religious with your coolant changes, and whatever coolant you get, if it doesn't already have a silicate coolant additive package in it, I recommend that you get one of those, because the silicate additives keep it from, or the silicate additive replacement keeps it from eating away at the cylinder walls. Let me see. Okay, over here we have the Rusamaster or Stanadyne DB2 plunger type injection pump. This maxes out at 57.5 millimeters, cubic millimeters per stroke of the injection pump. That's its maximum fueling rate. This one is, I don't remember what the governor style is on it, but I need to take this one apart anyhow and free up the plungers and rebuild it a little bit. This is, I think, off of a turbo engine, so I don't know what they did to the pump. If you see these pumps leaking, they're not terribly difficult to take apart. You can unstack them from the nose cone. You can take this head out of the body, and you can take the shaft out the back of the block. You can get reseal kits for these for like $40, and they come with all of the things that you need: sands, plungers, and other internal components. This is your top cover. They call these a one-wire diesel for a reason. All that you need to do is supply power to this stud, and then ground to this back stud, and the engine will run, because the fuel shutoff solenoid will close there and will allow fuel through the injection pump. So, leading to another common problem. Well, first of all, these pumps can be weak, so if you ever replace injection nozzles, it is recommended that you do all the injection nozzles at the same time. I recommend getting Stanadyne or Delphi replacement nozzles instead of rebuilt ones. I've had bad luck also with rebuilt injection pumps causing smoke, no start, and low power issues. Severe no power issues. Another common problem is these return lines. So coming back to the cylinder head, you all have probably heard of these infamous plastic return lines. It's a very cheap and chintzy way of doing it, but as you can tell, these plastic return caps sit over the top of these injection nozzles. Let me set you on my knee here. But as you can see, this return cap, oh, it's not focusing on me. Okay, there we go. Nope, almost. Fits over like that, and then there's 2 O-rings that sit in this injection nozzle, like so. And then these rubber return lines direct fuel from this back to the tank. So these return lines will crack and age, and every 3 to 5 years you should probably replace them, because they will leave you stranded. Another thing that I really hate about these IDI fuel systems is, you can't see it here, but there's these rubber fuel olives that live inside of these single flare fittings, and these fuel olives are a big source of pain for me, at least, having to replace them constantly. This is one of the fuel return lines that runs down the valley of the block, so That's the front of the valley pan right there. So your injection pump would be sitting right here, and this runs up to the injection pump. And inside of this junction as well, there are multiple fuel, or there's a fuel olive here, and there used to be one here, but whoever owned this was smart and cut that piece of shit off and put a chunk of hose on it. Hopefully they single flared it, or they used one of a double flare tool and did the first part of a double flare to keep that rubber on. Not my concern. They are pretty bulletproof engines because they are so low power, but they do have their quirks. It's like a Harley Davidson, i.e. it's so low power that it won't ever wear the engine out. Whereas a DT466, a 7.6 liter, which is marginally larger, will cause problems if it's not taken care of religiously. I take it the newer ones, the electronically injected ones, can develop blown head gaskets and oil consumption problems. But I'm not a heavy equipment mechanic, so I couldn't tell you. Now this is an example of a dual mass flywheel. This is another one of the hated things about the ZF 5-speed transmissions that back these up to Zunfolge, or I call them Kraut-built transmissions. Goddamn German puzzle box. But this mitigates the vibrations caused by this very, very robust diesel engine, which they claim will wear out the bearings. I don't know. It's just ZF being stupid. My truck, that old white diesel that I have on the channel here, it has a single mass flywheel conversion in it. God bless whoever did that. They also have stamp steel timing cover in the front and a stamp steel rear crank seal in the back. This is the gear-driven oil pump out of that same engine. As you can tell, if it doesn't have any play, you open it up in the gear teeth, then it's pretty much guaranteed to work. I usually put a little bit of heavyweight engine oil or gear oil in them when I'm putting them back in the truck, just to make sure that they have prime and that I don't run the engine without oil. These are a pair of remanufactured cylinder heads that are absolute pieces of shit from Odessa Cylinder Head out of Florida. I recommend getting a $300 or $500 pair of verified magnafluxed and cut heads, and then putting valves in them yourself. You'll be a lot happier than spending $1,900 on something that is shittier than the work that you can do in your garage over the span of 4 or 5 weekends. Let me see if I have one. No, I don't think I have a rear main seal in here left. But this is a front crank seal, but the rear crank seal looks very similar to this, but it says install dry because it's a PTFE seal. This front crank seal and the other national rear crank seals are not, so you install them wet. I usually lubricate them with engine oil or grease. Standard valve cover gaskets and valve covers or rocker covers, depending. There's a bunch of different sensors that live on them. I don't remember the part number for these crankcase decompression regulators or crankcase depression regulators, whatever you call them, but this serves the same purpose as a positive crankcase ventilation. There's your part number. If you need a CDR valve, I recommend going Ford for these, but the only place you can find them is on eBay. This is only tangentially related, but this is a ZF5 with a 420-pound rating on it. I just put this in my truck, and it is locked into 4th gear. I don't know if you can tell, but, the synchronizer ring here will not move back and forth. I am forcing against it, as you can tell, and I am moving the whole transmission. So this sucker welded itself up, and I got to take that transmission right back out, which I guess I'm good at taking ZF transmissions out now. But you can see this one moves pretty well freely, which it has to move just a little bit inside of that hub and slider assembly. Otherwise, the slider here cannot synchronize. It cannot force this blocking ring up, and the tabs keep it from going over and engaging the teeth on the actual gear here before the synchronizing action against the cone clutching surface of this input shaft has been achieved. It's actually a pretty clever little design, but I don't really know how it welded itself up. Maybe I used Mercon 5, and maybe that caused the problem. I don't know. This is a 6.9 liter IDI head gasket, but it illustrates the problem perfectly well. This is a composite head gasket. I recently learned that these are made by the Better process, or the Beater process. These are made out of asbestos, graphite, etc., and they're stamped into place with these steel fire rings. And then at each end there are these rubber, Viton rubber O-rings that seal in coolant. Those are coolant passages. This, however, will indicate just exactly where your head gasket's blown. As you can see here, there's a lot of soot, etc. Well, the light's not great over here. Let's do this over on the workbench where you can see it better. All right, let's move some things around here, get these out of the way, and get all my shit greasy because I'm a grease pit. Okay, so these composite head gaskets are older technology. I think they came around in the 1940s with the better process with World War II, and they really tried to phase them out in the 1990s. But you still see these popping up randomly from place to place. Anyhow, you can see how this area is eaten away by combustion gases, highly acidic, highly corrosive, or not acidic, highly corrosive, high temperature combustion gases, rather, which eat past this fire ring. This is another problem with these. As the cylinder, or as the engine runs, the cylinder head gets lifted away from this head gasket in such a manner by upwards of 1/1000th of an inch. While these are running under full load, they can experience anywhere between 3,000 and 4,000 pounds per square inch above the piston, which can in turn cause head gasket sealing issues if the engine is overheated. But again, you can see where this has just been eaten away and where soot is really intruding into the head gasket. Okay. Well, I'll go illustrate next the problems that are had with the sealing of that injection nozzle against the cylinder head, head's bore and seat in there. I was talking to a gentleman who works at Napa. He used to bend wrenches, and he was mentioning to me that you can put crush washer after crush washer after crush washer in there and it still won't solve the problem. So what I usually do to test that is grab something like PB Blaster or WD-40 like this, and then shake it up, and then I'll spray it around the seat where the injection nozzle, or not around the seat, around the threads rather, that are exposed near the cylinder head. So I'll drop an injection nozzle here. This one still has threads on it. There's one that doesn't have any threads on it anymore. This one. This was one that we used to pull another one out of these cylinder heads. Another part of an injection nozzle. But as you can tell, this injection nozzle would sit about like this in the cylinder head, and there would be threads here. And so normally, when I first start the truck up, I'll spray some PB Blaster in here, see if it's leaking, and then I'll continue to run the engine. What I've noticed with these engines is generally if you have one of these seats and it's not too far gone, the engine will run fine. It'll actually have some oomph behind it, but as it warms up, the misfire will get worse and you'll be able to start hearing it misfire as the engine's running. So that's just something to be wary of. If you have the proper bits, I'm sure that you can recut the injector seat and get your crush washer to seal there. But again, I'm unsure of how thick the cast iron is underneath of that injector nozzle seat, so that is something to be wary of. Try to take away as little material as you can if you were to try and recut that injector seat. Another thing to note, if you want to get that seat cut flat, then you can measure the diameter of this pedal tip right here above my middle finger. And then get a drill bit or something else that is the same diameter and use that as a pilot to keep that flat and concentric inside of the bore that injection nozzle seats in. That really does outline, verbally at least, the common problems with these engines. I did have the main caps off and the rod caps. I'm going to pull the piston so I can hone the bores, but it's very common to see, well, some shit fell down into these, but to see scoring along the inside of these cylinder walls, as well as to see severely scored piston skirts. Excuse me. And that can happen from a lack of oil. I took apart 169 where all the cam bearings had been wiped out in it, and the rod bearings in it were likewise pretty well seized. It had lower than normal oil pressure, so it's another thing to be wary of. I always inspect the camshaft journals too if I have them apart, and I might go ahead and pull this camshaft out. They're not hard to time. You just line up a couple of dots over here. I think it's their older ones are Y to Y and the newer ones are dot to dot for the injection pump, and then I don't remember Maybe there's Ys. Yeah, as you can see, there's a Y right there, and then there's a dot right here, and there will be 2 dots on that crank gear, or on the, sorry, injection pump gear, and you put this dot between the 2 dots, and that'll align the teeth properly. Or maybe it's, no, it's these two dots, I think, get lined up. Either way, don't trust me. Refer to your service manual. I use this Ford OEM 6.9 diesel engine supplement because these are basically the same engine. This one's just been bored over. The valve trains in the 7.3s I've heard are a little bit heavier duty. I haven't been able to notice any differences between the two, but whatever. These 7.3s also utilize a 1/2-inch cylinder head bolt versus the 6.9s utilized a 7/16 shaft diameter cylinder head bolt. So that's something to be aware of. The heads do not interchange between them without some machining and creativity. Just a beautiful day out there. Looking towards the mountains to the south. All right. If I think of anything else, I'll interject it somewhere in this video, but I don't anticipate that will be it. If your IDI blows a freeze plug out the block, then suspect a cylinder head gasket. That's one of the engines that I bought. I bought 2 6.9s and a ZF off the internet, and all 3 of them have fucked off on me. So I would not recommend buying parts off the internet. Or if you're going to do it, have them rebuilt. And these are getting harder and harder to find parts for. Oh yeah, there's the Vane type power steering pump, Saginaw or whatever. They always whine, but I've had good luck with them on these IDIs. They're a little heavier duty. Oh, here you go. Here's the turbo. So everybody loves turbos on these IDIs. It really does wake them up. And they need it, you know, turbos and diesels go together, bread and butter. But the problem with these IDIs is they're such a high compression engine, right? The original 1983 6.9s had a 20 1/2 to 1 compression ratio. The 6.9s after that, 84, and then the 7.3s had a 21 1/2 to 1 compression ratio. So if you start forcing extra air into them, they don't cotton particularly well to it. It does wreak havoc on the piston rings. It can bend connecting rods and wrist pins, which again is why the turbo motors have a thicker wrist pins, keystone rings, etc. But if you're going to do this, I think the factory turbos, this is a factory turbo downpipe. I don't want to go digging through it, but I have a bunch of parts for it in here. Anyhow, yeah, there's a turbo manifold. But generally they run 10 to 12 pounds of boost maximum, 5 to 6 normally. Again, they're just such a high compression engine that you really do risk bending parts, etc., when they're running. They weren't originally intended for turbochargers, so that's why you see things like even an old 12-valve Cummins or the newer Duramaxes or Power Strokes have 16 or 17 to 1 compression ratios, so they can run higher boost pressures. They do sell, aftermarket manufacturers do sell pistons for these IDI diesels. Lower compression pistons, low deck pistons, that will decrease the compression ratio enough that you can force 20-30 pounds of boost into these without risking not detonation problems, but pre-ignition, hot spots, and bending parts. So yeah, hyper-eutectic piston too, I think. Don't quote me on that, though. Okay, so this is an example of an aftermarket glow plug. I absolutely do not recommend that anybody ever uses anything other than the Motorcraft ZD9. That is Zebra Delta 9 glow plugs. They're the bullet style glow plug with these small tips, and then they have a connector on the back, which is mirrored by a bullet style connector that comes out of a wiring harness. Don't mind me. But as you can see, this is what happens over time. These wiring harnesses get really shitty, they get really old and really brittle. I just redid all the wiring in the wiring harness in my truck, or all the glow plug wiring rather, that fits onto the end of these. I don't have the packaging here anymore, but I think it was Swag Performance Parts sells a kit for $14.99 or whatever that you can buy of heat shrink style glow plugs. I pulled auto lights out of these cylinder heads that came out of the block over there, and the tips of all of these were eaten almost halfway back. The guy that I bought it off of pulled one of the glow plugs and thought he broke it off in the head, but he hadn't. The tips of these had been eaten and eaten and eaten all the way back to right about there. Every single one. Do not buy anything other than Motorcraft glow plugs. You will break them off or they will detonate and fall into your cylinder head or into your combustion chamber. Another thing, people will use ether with these, and Sam was mentioning that if you use ether enough and you hard start it enough, that eventually these hardened in-canal pre-chambers will crack along there, and they can drop half the pre-chamber into the piston and destroy the engine that way. Ether isn't the hardest thing on them, but it's not recommended that you use copious quantities of it. If you plug it in and you use the glow plugs, right, because these have a solid state controller in them, so the solid state controller expects to see a certain amount of resistance and a certain voltage, and if one of these glow plugs burns out, then the resistance becomes too high in the circuit for the amount of amperage that it's trying to pass through at a set voltage, and so the solid state controller turns off. And then it turns back on, sends some voltage and amperage to the circuit, sees that it's, too much resistance, and turns off. And that's why they short cycle and click, 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 on and off, back and forth. That can be an indication either that one of the connectors right there that I just showed you is burnt out, or is arcing, or has too much resistance, or is broken, or that the glow plug itself is burnt out. You want to see between 0.01 and 0.06 ohms of resistance, I believe, between this pencil tip and I just tested the threads to the body of the glow plug because they ground through the cylinder head, which is another reason engine grounds are important. I think the fuse is rated to 100 amps for these engines, but I think they draw between 40 and 60 amps, depending on how cold it is outside. Okay, I covered ether, covered the glow plugs, the wiring. Yeah, these IDI diesels don't start well in the cold because you see how flat the cylinder head is, and it's a 21 to 1 compression ratio, 21.5 to 1. So as that piston comes up, all the gas is forced out of the area above the piston and up into this pre-chamber here, which is fine and it works, but all of the heat that is developed inside of this combustion chamber, at least this is my working hypothesis, is all that heat that's developed in the combustion chamber by the compression of the gases between that piston, which is traveling up in its bore, and the stationary cylinder head and valves, is dissipated inside of this pre-combustion chamber. Right, so any residual heat that you had inside of here, it really does get sapped away. But that really wouldn't make sense to me if the entire engine is 3 degrees below 0 Fahrenheit. Then the whole engine is going to sap heat away. It's odd to me that they don't start well in the cold, but they will not start without glow plugs, it seems, unless they are like freshly shut off from being hot. Another thing, people always claim that these engines can't be run at high RPM, but if you consider people build big block Cadillacs, Chevrolets, like those old 472 or 500 big block Cadillacs, or big block Chevs, big block Fords, and they'll run them up to 5,000 RPM with the right valve springs, and the same is true of these IDIs. If you adjust the valve train, i.e. the push rods, the cams, the lifters, and the valves, as well as the valve springs and the rocker arms, you can actually get these things to turn upwards of 4,500 or 5,000 RPM. I have no interest in doing that, and I don't have any resources to back me up, so I'm not going to actually make that claim in earnest, but so I've heard that is what you can do to these engines. Either way, these engines will run happily anywhere up to their fuel-governed top RPM of 3,600. I've towed with these just fine, turning 2,800 RPM, 2,900 RPM, doing 75 or 80 on the interstate, and haven't ever had a problem with them. They sing, actually, quite happily. They like revs. Zip ties and bias plies, I think, is correct in that assertion. These engines really do like revs. Sam was also mentioning that, the gentleman I talked to. These motors like revs, so that way they can flow more air and produce a little bit more power. They aren't like a big old NH or NTC Cummins where they don't like going fast. They're torquey, but they need rip'ems to produce their optimal amount of power. Okay, well, my phone just shut off, but I don't think I showed you any of this, so hopefully I'll remember to kill that last video. So, oh, this one's perfect too. Right, see, this part of the wiring harness came off with it, which is another reason these glow plugs suck. The wiring on them is just awful. But look at that tip. Look at that tip. And notice how every single one of these glow plugs tips are eaten away. Look at that. They're supposed to be nice and round, and they're supposed to be a little over 1.25 inches long. And what are all these? 1/2 inch, maybe 5/8, and they're all eaten away. That's really bad for your cylinder walls. It's bad for your valves. It's just bad for your engine. Don't buy Autolite glow plugs. They're awful. These are standard type hollow push rods that supply oil to the rocker arms. They're interchangeable, of course, because they're a hydraulic roller lifter. Then here are the rocker arms. They exist simultaneously on a bridge that returns them to their position as they flex. Pretty bulletproof, really. But yeah, again, if you know what you're doing and you buy quality parts, you won't have these problems. But flounder long and hard enough and you still don't have any guarantee of success. All right, another two problems, air filters and glow plug. So one of the things that people hate about these air cleaner assemblies or air filters is, well, this is an air cleaner assembly, but this big bowl, people always claim that it's super restrictive to the flow of the engine. I mean, it's such a low power diesel. I really suspicion that's not a huge deal, but yes, if it helps do it, to cut that out. Let me see if I can't find any glow plugs here. Oh, I thought I'd left them. I'd left them somewhere over here. But have to bear with me for a minute here while I look through my shit. Yeah, there's the thermostat. Always buy a Motorcraft thermostat. The aftermarket ones don't cotton real well. These old IDIs. And then usually I put the jiggle valve facing up, but it depends. Some Toyotas require that you put the jiggle valve facing down. Here is the rear main seal housing, and there's the rear crank seal. This one's brown, so it's probably an aftermarket national seal. That one you install wet. Good Lord, where did I put those glow plugs at? Might have just thrown them out, but I'll have to find those. So, if you noticed, that injector was already bubbling and the engine hasn't been started, right? There's a good bit of pressure in the radiator. Coolant hose is ice cold, so that's going to cause a misfire. Although the smoke in this diesel generally clears up after you let it run and get a little heat into the engine. But you'll notice how I had the throttle pedal depressed and it still started relatively easily compared to when the glow plugs don't work or aren't being actuated. So I think that pretty well concludes the overview of common problems with these old diesels. They're finicky, but if you know what you're working with, and if you know how the system works, and you screw with it for long enough, i.e. 2 years, and you actually get comfortable with it, then things start to make sense, and you're able to quickly and concisely diagnose problems with these diesels. Another thing, compression numbers on these trucks, we're up about 5,100 feet above sea level, so we see severely reduced compression readings. However, up here anywhere between 300 and 330 pounds per square inch is pretty normal. Down at sea level, upwards of 370 to 390 is fairly normal. Again, it just depends on the health of your engine. But realistically, the readings should not be any more than 15% apart. So you take the mean and then see how far each or you take the highest reading and then you see how far of a percent difference the lowest reading is from it. And if it's more than 20%, or 15% rather, then you know that you have some issues and the engine probably has a valve sealing problem or has worn piston rings. Well, thanks for watching. If you have any questions, feel free to post them down in the comments. I don't figure many folks will see this, but you know, if you do and you find it helpful, then great. And if you don't, then please leave a dislike. Dislike it anyways. I always like it when people dislike my videos. Of course, YouTube doesn't let you see how many people dislike you because they don't like people getting ratioed because they're a bunch of libtards and beta cucks. But, you know, we don't need to focus on that right now. Don't worry, the future's in these people's hands. They know what's best. Okay, so the final thing that I wanted to go over in this video was the things that I forgot to mention earlier. So the first of which is the oil cooler gasket issues. The O-rings which seal the coolant and the water away from each other inside of that oil cooler instead of that external type oil cooler can cause issues where you get coolant in the oil. More common with a head gasket is that you'll pressurize the cooling system. They don't really eat coolant because they're so high compression. At least that's what I found with that 6.9 that I blew head gasket in. Well, I bought it with a blown head gasket, but that one pressurized the cooling system. The oil cooler gaskets are what'll mix oil and coolant, at least from what I've seen. Second thing, compression loss from the cracks in the heads. So it'll cause white smoke issue. It'll cause a lack of power as well, because it's leaking compression through the cylinder heads. It can do it into the cooling system, and it can also do it past the intake or exhaust valves, back up into the intake or exhaust manifolds. That's really the main concern, is loss of power and white smoke, and you'll never be able to get rid of that white smoke with, injection system things. You need new cylinder heads. Third thing is the crank wear patterns. So here I've drawn, this is sort of a side view of a crank shell, and then this is more of a top down. But when I pulled that motor that I had on the stand apart and I pulled the main bearings out of it, it had two spots that were worn, because these are 3-layer bearings. So there's, I think it's babbitt, and then aluminum, then copper, then the steel backing plate is how they are, or how they're layered rather. And it had worn all the way down through in these two spots to that copper layer. And I think that was because somebody had run it hot, i.e. they'd had a turbo on it and they were pulling really hard with it. It's pretty common for these two white bearings, but this wear pattern indicates that you should probably have the crank checked at least in a pair of V-blocks to make sure it's not warped, because this can indicate odd wear patterns. It wasn't just worn down the middle, it was worn offset, i.e. the piston was coming down this way on its power stroke, and so that was where it was wiping it away, because you got a piston here and then a piston on this side opposite it. So it kind of makes sense that these mains had worn that way. And the crush washers in the cylinder head, I think I addressed that properly, but again, if those crush washers can't feed against the head, you'll have a loss of compression and a white smoke issue. Excessive fuel consumption. Normally these motors should get between 15 and 25 miles per gallon, 15 city, 25 on the highway if you're really conservative, maybe 18 towing on the highway, 18 or 20, but again, if you've got misfire, lack of compression, you're having to work that thing hard, it'll get maybe 10 to 12 miles per gallon, which is what about I'm getting, especially if you have to warm it up all the time. Final thing, you'll notice how in one of those videos a bunch of coolant came out when I opened up the rad cap. That was because I didn't have any headspace in the radiator. Normally it likes about half an inch to an inch of headspace beneath that. So you got the radiator filler neck that goes down, and then you've got the body of the radiator, and you like some headspace but up there. Keeps it from pressurizing the cooling system unduly.